All right, let's begin. To our Twitch viewers out there, thanks for hanging out with us this evening. We really appreciate it. I know our streaming schedule's been chaotic and we haven't been streaming, but work's gotten busy. So it's kind of chaotic for me. Usually I'm just too tired when I come home. And with everything I've got to do, get up in the morning, go to work, whatever. It's just very difficult to catch up on and do that as well during the week. So we'll do it when we can throughout the week and try to stick to at least Saturday and Sunday, except with, the most recent Saturday, not really able to, is just not feeling that well under the weather, just kind of burned out a little bit. Needed to take a step back from how busy the week was. To the YouTube viewers out there, thanks for hanging with us and checking out another video in this series. This is a long-winded series. I know it's dragging on, but that's the way it goes. Many projects are not one and done. So let's just keep going and enjoying this ride. So we left off the last video with starting doing the schematic capture for the fan tester, the multi-fan tester. So we're just going to pick up where we left off and kind of finish try to get as much of the schematic capture as possible. So let's get these guys wired in here. So this is the big terminal block. Worry about that here in a minute. This is our fan connector. So what I'm going to have to do, KiCad, I don't know if I've got a schematic output of that. So let me see if I can get to it real quick. Forgot to check for that. Okay. Stepper controller, because I want it to match the fan. Hardware. Here, nope. Project outputs. There's the stepper controller schematics. All right. So let me go to the fan, which is going to be for where the stepper is. I just want to make sure we match pin for pin. What we did here. There we go. There's the driver. There's a fan. So let's go here. All right, so here's this guy. No. All right. So pin 1 was our 5 volts. Well, it's going to be our fan VCC, which will typically be 5 volts for this particular unit. So let's also get this guy. Get this guy out of the way. Stop. Drag it out of the way. So ground was on pin 4. Stop. Ground's on pin 4. And then I still got to get used to that. So we need net labels. Fan VCC, which is going to be pin 1. All right. Pin 2 is fan tac. And pin 3 is fan PWM. All right. So there we go. We have, that is for this guy. Interesting. Typically 5-volt DC. Boop. Okay. We have that guy. You guys out of the way. And we'll kind of get all this kind of snugged out of the way. CN4, that is the terminal block that we chose. And since we haven't defined anything yet, it almost doesn't matter. Let's just kind of... All right. So we're just going to follow the other one. Fan VCC. Tack. And fan PWM. Now, obviously, you don't want all of these connected at the same time. Just one at a time. But hopefully that will be kind of self-evident. So let's go ahead and see about organizing this to make it look a little nicer. Maybe we'll do that here in a minute. Okay. 20 ground. I think we're okay on that. And we've got our grounds here. Pull up for the tack. They'll all tie together. Nope. Stop. Come on. ICAD. We'll kind of drag the stuff around. Make it look... Make it look... Hello? Oh, I hate hitting those buttons on my mouse. Stop. Jeez Louise. Half the struggle is just getting things to work the way you want it to. Without double clicking on anything or what? Jeez Louise, dude. All right. So that is going to be a wire out on this guy. And oh, wow. Hmm. Come on, guys. Go. And that's fan VCC. All right. Okay, so those are our selection voltages for the fan. You know what? Let's copy this. Spell properly. All right. Voltage selection, only one at a time. Get this guy cleaned up. Come on. Hey, come on. Goofy. All right. All right, so that's the fan voltage selection. These are fan tie-ins. Boom, boom, boom. There we go. Okay, so those are our fan connections. That should be fine and beautiful. So our VCC, so we've got them all common over here. And this is where we're going to get our power. We'll indicate all that on the LCD. I think what I might do to add some visuals. Let's see here. I don't. DL. Okay, red, green. Okay. So this is what we're going to do. Let's clean this stuff up a little bit. All right. So let's see here. USB 32. Okay, I'm gonna look see what kind of resistors we chose. Okay. No, stop. Jeez Louise. Now I've got one for. I know we've got resistors. I'll just figure out. Choose a resistor for the. Okay, 3. Okay. Okay, for the 3v3, we got a 330 ohm resistor. Nope. Jeez Louise. Stop, KiCad. RC0603. 330 ohm, and that is for the 3.3 volt. Here we go again. I keep forgetting which scrolls and which. That's my own stupidity. This way, we'll also have a visual indication to which one is selected for the fans. So we don't accidentally blow ourselves up in the face. I mean, that's an exaggeration. We can probably push this up a little more. Close. Yeah. Yeah, here we go. Let's. Ground down here, and then 510 ohm to be good. Stop. Close this bridge a little, or close this gap a little bit. ground in there. So now we're going to have to figure out what the resistor value we want. All right, here we go. Time to do some math, kids. Hooray, math, my favorite. All right. So we need to, I think I set them up for, how many milliamps? Let me figure it out here. See a little calculator. V over R. So that's 5 volts. 5 divided by 510. What 3.3 divided by 330. About 10 milliamps. Okay. So R is 12 divided by 0.01. 1.2K. Do we actually have a 1.2K? Oh, that'd be beautiful if we did, please. So C06. No, we don't have a 1. We have a 1K. 1.2K. Slightly brighter than the other ones. Let's see here. That's current would be 12 divided by 1. Would not be by much. It'd only be 12 milliamps versus 10. It'd probably be almost indistinguishable to the human eye. And since we're not enabling, you wouldn't be enabling both at the same time. I really doubt anybody would really notice that. Again, sometimes it's best just to keep your bill of materials and your inventory. You know, oh my gosh, I am such a turd. All right, let's try this again, kids. Forgot to put the LEDs in here. Okay. Oh my goodness, I am such a turd. Okay. So I'm going to probably need more room than that. But that's fine. I can move that stuff over. Hello. More worried about picking a resistor than actually making sure the LED's in circuit. Okay. So, back off the sheet for now. No harm, no foul. Grab this jive, pull it over here. Grab this junk. No, don't need you. Don't need you. Move you over here for now. All right. Oh, I am such an idiot. All right. The selection. All right. No. It doesn't help that these symbols are just ungodly large. But, you know, it's fine. Try to line up as best as we can. And if we're going to be, it's perfect. I tried pushing this over the PCB and I'm like, why isn't it working? Why is it acting broken? That should be fine over here. Now maybe I can do it this way. Yeah, there we go. Let's do it that way. Yeah. Stop. It's because I repeatedly love punching myself in the face. There we go. All right. What we can do. Excuse me. Make this just look nicer. Let's narrow that up. We don't need that. Big. Right. A little bit messier, a little dirtier. Let's go here. What we can do is just grab this. Let's see here. So yeah, you could use this to test even fans without PWM or tag. So if you have a PC fan, you could, one of the standard style that's just 2-pin that has that that type of connector that has this type of connector on it, and plug it in and it should still work. You just won't get a tag signal or anything, or be able to control PWM. Or if you got a leaded fan that matches the voltages, so something doesn't seem right. Did I put no? Oh, that's right. I don't have a. Oh, let's get the Oxford comma in there. All right. Let the grammar police come after me. All right, so let's grab this guy. Throw it down here. Alrighty then. Okay. Well. All right. So I'd say right now we're pretty much done with our connectors side. So there's our jumpers. Now we need to figure out some of our other. Oh, here I go again, yawning. Woo! What a day. our input structure. So we want like a start stop button for testing, basically to turn on PWM or whatever. Not like it really matters, but we could set it up to control the power supplies, but I don't really think we need to do that. Basically, start stop. I mean, that only really do anything for the PWM side, so almost doesn't really matter. Because we can have, so maybe just two buttons for PWM increase. Maybe just have it incremental, like, basically increments by a value of 10. Basically 10% of PWM value, you're going to have it mapped. And then just cycle back around to, 0 to 100, basically, increments of 10. And then we could see, basically what it's sending to the fan on the PWM side, basically the PWM value, and then basically what the TAC is reading. There's a bunch of other things we could really do if we wanted to, but this device, simpler is better. Simpler is better. We could put something in here to basically register a high off of either one of these and send it to the ESP32 to let it know, like, this voltage was selected, or this voltage was selected, or this voltage was selected. We can use something like a supervisor with different voltage supervisors with different thresholds, like a 3.3 threshold, a 5 volt, and a 12 volt threshold. And when those are reached, it basically would indicate to the ESP32 that fan. But again, let's keep the BOM and the build simple. There's no need to throw in overcomplicated parts. So have we pulled out? Okay, we have not pulled out the fan TAC or anything. So let's go over here. All right. All right, so I haven't pulled a port over from the other side. Oh yeah, I did. So I've got ports right there, kind of backwards over here, but it's fine. Copy those, come over here, paste them. Okay. So let me reference. So we know the current design works. Okay, so fan TAC is on IO22. IO22. Stop. And PWM is on IO23. And that's going to be an input. That's going to be an output. All right. So we have fans. We have our I2C for our LCD display. We have the port for program, the FTDI interface. Now we're going to need our buttons. All right. Oh, again, wow. Okay, so since we don't need a button or a big buttons, do I have under switch? Yes. So these are going to be our program buttons, boot and ESP-EN. Okay, so go and make sure I get things copied right. There we go. All right, so we're gonna need no, I'll get rid of that one for now because we're going to just all right. Bump, bump, bump. So we're gonna get all these guys. All right, and then the two commons tie together. I'll worry about that here in a minute. Nope. So I think, okay. Actually, I don't need to do that yet. Nope. Let's see here. That will be enable, ESP enable. That will be boot mode. Yeah, we'll just have to manually control it for programming, but for what it is, it shouldn't need too much special programming. You know what? I throw another TBS diode on here. All right. Yeah, so one of the general rules you should always try to follow is to put a TVS diode on any sort of input where a human hand could even come close to touching it. That little, 10-cent part could, be what protects the device overall. So now I want to select buttons. Basically your increment decrement buttons. Now we could have it just one button to where it just, increments and it rolls over. But we could also, have it to we could have maybe 3 buttons: increment, decrement, and reset. Test reset or something. That way it sets everything back to 0. That way maybe you can set the next test. Always decisions. So I'm thinking, we're going to have some footprint anyway because of the LCD screen. I'm thinking, well, let's figure out what buttons we want to use, because these guys right here, they're small. You've seen them. They're small. And those are kind of perfect for the program and boot mode. They're perfect for that. But for inputs to where chunky hands might have to mess with them, they may not be. So I'm thinking about these fellas right here. They're 12 millimeter by 12 millimeter tactile buttons. They're big, they're through hole, but it doesn't matter because there's already a couple of through hole parts on here and it's not going to be that big of a deal to solder these guys down at the same time. Their price isn't too bad for maybe 3 of them per board. It wouldn't be that bad at all. Again, they're big and chunky. They're just for signals. They handle the voltage. Current's fine. Yeah, they're going to be huge. But you know what? I'm fine with that because sometimes these buttons are a little too small. So let's go ahead and get the files for them. Let's get that opened up. Downloads. Extract all. Get them extracted. Okay. So you know this is going to mean more part entries, but you know that's just the way it goes. Let's go here. Okay, so let's go over to KiCad. Boop. Symbol editor. And footprint editor. So let's first get the footprint pulled in. File, we're going to import a footprint. Oh, this is so much fun. All right, hopefully they have a KiCad in here. If not, I'm going to punch myself in the face, repeat it, and they do. As for a switch. All right. Now, oh, okay. Okay, it's going to be under components. Bam. All right. Now, let's file footprint properties. So, embed file. We're going to models. We're gonna trash that. We're on plus. Okay, we're gonna save it, and if it worked right, when we go to here, no, embedded files. Okay, save. Ah, there we are. Yeah, there we go. All right, so no. All right, there's no easy to see pin 1, so I'm not going to worry too much about that. Oh, these offset way too high, probably 0.25. And all right. Models aren't 100% necessary. I'll keep mentioning that. 6.1. But they're really great when you're trying to get a general feel for what your board's going to look like. Like when you want to do a 3D view. Again, not essential, but it's really good idea to see what it's going to look like. All right. We've got the footprint. That is a fabulous symbol. Now let's see if we can import the symbol. Oh, components file. Not like it really matters. Make sure we get the right symbol. Go, open. All right. All right, file, properties, home, SW, there we go. Give it a rename. That's okay. Now, properties. Get rid of that. We don't need to show that. Let's get you opened up. our pulp. You. Okay, we're going to save this because, you know, again, I keep forgetting to actually formalize this. We'll probably change this. Well, double pull to go through. Single pull, single throw. So they're all like tied together anyway. So I think what we're going to do is we're going to rearrange the symbol here in a minute. Properties, okay. Let's get some of this. Get these matching. Manufacturer part number. Manufacturer 1. Vendor 1A part number. Mauser. Manufacturer. I like how I can do that. Oops. Calls flow volume. High volume. We're also going to add another one. Okay, so manufacturer low volume is 0.25, high volume 1000, 0.149. Get better breaks at 5000, but that's a huge. All right. All right. So let's okay that. Save it here. I'm going to pull up this switch mainly because I'm going to grab cancel file, simple properties, switch tactile, single, no momentary. By 12 millimeter. 6 millimeter. 12 by 12 by 6 millimeter. 12 volt. 50 milliamp. Laws. Put in. That way we know it's not, SMT. It just helps. And because we have to get this added to Odo real quick, new. That way we don't have to do it on the road and we don't punch ourselves in the face. Okay. Switch. All right. All right. It's in that system. We have our footprint. References SW. Volume 10, 12 millimeter, 12 millimeter by 6. Now, what is... So it's... All right. There we go. There we go. There we go. We are good to go here. Let's save that. And so we have the symbol, the footprint. Now to throw it into our schematic. Is that extremely long? All right. SW. Two. Let's go 3 of these guys. All right. Take up a lot of space on the PCB, but it's fine. Like I said, it's going to be a pretty good size because we're also going to organize the fan connectors so they let's see here. Okay, so these are going to be pulled down. We're going to be looking for active highs. You know what? Why am I wasting time? Oop. Let's do this. Let's design one of them and then do the rest of them. You know what? Same thing we did. Let's view out of the way. All right, KiCad, come on. Play nice, play nice. Let's go here. Stop. All right. Wow, stop. Down. Looking for active high. Wow. It's connected here. All right. Go. Okay. Then we'll get our signals. All right. Reset switch. Increment. I probably spelled that wrong, but it's fine. Decrement. Probably spelled them wrong. It's fine. Okay. You know what? I care. Let me look. You know what? Increment. I spelled it right. Now. I spelled that right too. Wow. 2 for 2. It'd been even funnier if I spelled reset wrong. That even more comical. It's like, dude, what are you doing? All right. Oh, I can actually kind of sit down here. You switch it. Oh, you stop! Oh, I hate those buttons. They come in handy. All right. What? You down here. Stake you. Oh, I should be. All right. I'll probably want TVS diodes. Do I have any single TVS diodes? Like maybe SOT 23s or SODs. Let's see what we got here. Yeah, see, there's dual. But, I mean, it's fine to have a wasted one. Wasted channel. Alright, so I do it's fine. So come here. Does it go here? All right. That way we have TVS. Right now it's unused. All right. We know these two GPIOs are input only, so let's go and use these guys. It's gonna be a reset switch. That's gonna be increment. All right, and then I think IO2 is input only. That's gonna be decrement. There we go. Not like what I'm doing is actually important, but it makes it look prettier. All right, so we have our decrement, our switches. Oh, all right, you've made me sad. Oh, don't you? There you go, that special button. Hello. Oh, there we go. That's fine. Beep. go. Stop. There we are. Let's make it look pretty. All right. Okay. So, let's see. We have our boot mode, our enable. We have the switches for that, the buttons for that. That's got to pull up. The enable's got its pull up. Okay. We've got VCC. We've got ground. We have our I2C ports, our fan control pins, and our reset switch, our increment and decrement switch. Buttons, but switch. So, let's see here. Is that all we need for this project? Because I think so. Because we have our power supplies over here. The LCD will be a separate build like usual. Like the fan was. Okay, so we have our 5-volt DC. Our fan connections right here. Got our LEDs to help us indicate which voltage is selected. We'll have markings and silk screens on the PCB to help. We're going to try to lay things out very, very clearly. Double side populate. All right, so let's see here. That looks good. I can't think of any other signals we need because of how simple this device is going to be. Again, there's no point in putting an on-off switch on this thing. No connect. All right. Okay. Push that switch. That's going to go through that way. Reset. Okay. All that'll do is just reset the program, basically. Reset the increment, set the PWM value to 0, which will effectively turn off that fan. Again, we could overcomplicate it by having like a MOSFET actually, drive the power supplies, but not worth it. For what this is for, not a big deal. I mean, the fan will run for most non-control. Maybe we do. Hold on. Let's think about this. Do we want to do that? Do we want to control? And we've got more than enough GPIOs. Because we could use MOSFETs and effectively turn the power on and off to the do we want to? Well, then we could add another switch for start stop. Decisions, because we might want to. Let's go over to the fan connections. I mean, I've got room to throw the MOSFETs in here. We can drag all this kind of down out of the way. I can modify these circuits for the MOSFET control. We're only looking at like a they'd all get turned on and off at the same time, which would be fine. Decisions, my friends. Decisions. So do we have a MOSFET? If not, I've no one. I'll have to go and yeah. Um, don't know why that's in there. Oh, two. Somehow they got pulled into the components. I might have to clean up the library because we're not going to use that, I don't think. Yeah, so it's not even using it. Okay, I'll have to figure that out. So we don't have a MOSFET in our library, which I'm not opposed to putting one in. There's actually a nice little SOT 23 that 2 amps, which is more than sufficient to drive each of these lines. That may be what we'll do. Yeah, you know what? That way we can actually turn off all the voltages. A stop-start button. Yeah, you know what? Let's go over here. Let's go over here. Do I have enough? I actually have more enough room to drag this up just a little bit. Oh no, I didn't mean to grab that ground. Because all we need is all right, that is test control as opposed to pest control. All right. Yeah, I don't like how busy this is looking. I really don't. So we might actually create another schematic sheet and move a lot of this, some of this stuff over. It's starting to crowd out the ESP32, and I don't like this. I've never really liked this type of design work, so I think that's what we'll do in the next video. But let's go ahead and 35. Oh, get rid of that. All right, we're gonna grab test control. All right. And then what we'll do is, so that'll be an input from that guy. What we'll do is we'll grab, so the MOSFETs will all be tied together. So let's go and put a port in here. Port is going to be fan power control. Let's put you up here. You're going to be an output. Yeah, so I think that's what we're going to do. The fan connections down here aren't too busy. They're not too busy. The tack pull up, we can actually move up here. drop these guys down. It should give us enough room in here to drop in our MOSFET. All right. Yeah, so that's what we'll do. I'll grab the part number for the MOSFET that I'm already using on other projects. Because it's, like I said, it's 2 amps. So it'll be perfect. So I'll grab that MOSFET, and the next video, we will get that in here, get that wired up. Let's go ahead. Copy that. There's going to be an input. All right. Yeah. All right. Okay. So yeah, that's what we'll do. Is the next video, the next stream, we will grab the MOSFET, get its symbol in here, add it to the fans. That way we can turn them on and off. Because that way when you plug in a fan, you don't, you're not fighting it, cutting your fingers off or something, So yeah, that's something we'll want to do. So we'll take care of that in the next stream, the next video, and hopefully we can start doing a review, get all the stuff going, and start doing the PCB layout. But yeah, I think we're going to break this into a couple more schematic sheets. It's just getting way too busy, especially right here. That's just hideous. It's hard to read, pain in the rear. We'll port what we have to. We'll make ports instead of buses, but we'll take care of it. So I thank you for hanging out with me this evening. I really appreciate it, and we will catch you in the next stream. Have a good evening.